very long level train tracks. On those tracks, there is, of course, a train. The train itself is moving to the right with a speed of v. There are two people watching what's happening on this train. Over here, you see a person A. Over here, you see person B. Right here is person C walking on the train and person D who is standing on the train. Of course, person C is bowling because what else would you do on an open train car? Don't try this in real life. It's really unsafe. Person E and person F naturally are playing cornhole on the train. Okay, now you have the whole situation. Person A, B, all the way through F. They're hanging out on this train and they're all doing stuff. We need to discuss some relevant terms, so let's get into it. What's a frame of reference? Well, a frame of reference is the point of view of this train. First of all, what's up with everybody bowling on the train? Again, don't try this at home. The train has a speed of v relative to the track. The ball and person C, who's walking, have velocities measured relative to the train. So v ball is the ball's speed relative to the train. V train is its speed relative to the track. And vc is the velocity of person C relative to the car. So person D would say the ball is moving rightward with a velocity of v ball. But person A would disagree and say, no, the ball is moving to the right with a velocity of v ball plus v train. Person C would think that ball is moving to the right with a velocity of v ball minus how fast I'm moving. So v ball minus vc. Everybody's watching the same interaction, but because of their position, because of their frame of reference, they disagree on speed. Each person would graph that ball's velocity a different way. The velocity of the ball relative to the train is what one people at that moment. Let's see what they were thinking about. So there we go. Let's zoom in on those cornhole players. And let's see what they're thinking. Of course, remember, the train is actively moving. Person F is walking with a velocity vf. So person E thinks, hey, that beanbag is moving rightward with a rightward velocity of v bag times the cosine of its launch angle. Person B says, well, the bag is moving with that horizontal velocity plus the velocity of the train. And because person F is approaching that beanbag, they see it moving with v bag cosine theta minus their own velocity minus vf. So they would all graph the beanbag's horizontal velocity differently. Let's see what they say about the vertical velocity. Well, this character who's walking on the train throwing that beanbag says, well, initially the vertical component is v bag sine theta. The vertical acceleration is g. Wait a minute. Everybody agrees on the vertical motion of the beanbag because none of them are moving in the vertical direction. They all agree. They would all say, none of us are moving